All right, there we go. So did everyone grab the 3 handouts from the front of the room?
Yes.
Sweet. So if you're starting notes, you can title it 6.3 Properties of Trig Functions. If you want to keep your notes all nice and neat. That's what we're getting started on today. All right, cool. So the first thing we're going to be talking about today are reference angles. And that should look like one of the 3 handouts you got. So you can go ahead and glue that in right now.
Bro, we watched the bio. How you say it?
I was watching Curly.
Yeah, biathlon.
Yeah, biathlon.
All right, so if we can bring it back. I know some of you guys are still gluing in your handout, but if you can look up at the screen. So reference angles. So a reference angle is trying to get pretty much the shortest distance back to this axis right there. What's that axis called again? Is it the Y or is it the X? Yep. So reference angles, you got to remember, it's all about the x-axis. And so it's really important to be able to figure out whether you're just visualizing in your mind or you do a couple computations, which we'll get to later in the lesson, about which quadrant we're getting in. And so we were working on that a little bit yesterday, but it's really important to be able to figure out which quadrant we're in, because especially for reference angles, that then determines kind of how to compute our reference angle. So if we're looking first at quadrant 1, if we're in quadrant 1, the reference angle is the same exact thing as the angle. And the important thing too, one thing that you might get confused about is you might think the reference angle is how you would get back to the x-axis, but it's really just the positive direction. The closest way I'd say to go from the x-axis to the angle, but it's always moving in the positive direction. Yep. So positive direction is counterclockwise. Yep. So if you look up at the screen, positive direction is counterclockwise, negative direction is clockwise. So your reference angles should always be positive, and you're always moving in the counterclockwise direction. So great question, thank you. And in the first quadrant, your angle and your reference angle are going to be the exact same number. So if you're in the first quadrant and you see reference angle, you should be super happy because it's the same thing. So then moving over to the second quadrant, this is where it starts to get a little bit different. Your reference angle is actually the angle that goes from your original angle to the x-axis, and the best way to think about that, if you see over there, is 180 degrees minus your angle. That's going to result in your reference angle. And so from there, we move down to quadrant 3. And quadrant 3, at least for me, is probably the most difficult to visualize. But reference angle, your whole angle, right, starts there at 0 and it goes all the way around. Your reference angle is just going to be the little piece between the x-axis and the angle. And the way we can figure that out is you just take your angle. So that looks like it's about 225 degrees. It's kind of split in the third quadrant in half. So if that was 225 degrees, the way we'd be able to figure out this red reference angle is we would just go 225 minus 180, which is what's spelled out there. And so that's how you figure out the reference angles in the third quadrant. And then last but not least, fourth quadrant right here, when the x value is positive and the y value is negative, the reference angle just kind of completes the circle, right? And so the way we would compute that is 360 degrees in the circle. Reference angle is the difference between that full circle and the angle. So we just do 360 minus the angle. So let's say that's 315 degrees. The reference angle would then be 45 because 360 minus the angle, so 315, would then result in the reference angle 45 degrees. Any questions on that before we kind of get started with the examples? No? Good. All right. So sorry again for my sloppy handwriting. I'm still getting the iPad figured out a little bit. So that first example, the angle that we're given is 45 degrees. And so I'm going to give you 30 seconds. Hopefully it doesn't take quite that long to give me the reference angle if the first angle is 45 degrees. And remember, the first thing you want to think about is what quadrant is my angle in. And then once you figure out the quadrant, then you can figure out which equation you really need to use for your reference angle. How do I pause it for them? Not for me. It's this.
And then
Hold or-
yeah, hold.
So if you guys could hold up your fingers, what quadrant is 45 degrees in? Seeing a lot of number ones? Good, good. So then what's that mean our reference angle is? 45 degrees, perfect. When an angle is in quadrant 1, then its reference angle is the angle. We all good there? Any questions? Cool. So before we try to figure out 210 degrees, does anyone have a guess for where what quadrant 210 degrees is in? 3? Good. And the way I always think about it when I'm trying to figure out what quadrant it is I know where it intersects with an axis is, right? This is 0 and 360, and then it's 90, 180, 270, and then, like I said, 360. So if you're trying to figure out what quadrant an angle's in, the best way to do it is kind of think, what is it between? So 210 is between 180 and 270. Okay, that puts it right in the third quadrant. So I'm going to give you guys a little bit of time. Try to use that third quadrant reference angle formula to compute the reference angle.
Is the last one negative 275?
It is. Negative 275.
so worried about you.
Give me a thumbs up if you feel good about your answer for the second example. 30? You guys agree with 30? Great. So how did you get 30? Say that again? Yep, exactly. 210 minus 180. 100%. I agree with you. And we do that if you're more of a visual person, right? The reference angle in the third quadrant is just the difference, right, between the x-axis and the angle. And that difference right there we can see from the whole angle minus 180. So then I feel like you guys have a pretty good feel. So first, what quadrant is 305 degrees in? Fourth quadrant, right. So using that information, take a second and figure out what the reference angle is for 305. Oh. We'll get to that. Yeah, we'll get to that. Yeah. It's a little bit different because it's a negative.
Yeah, because I don't think I did my flip right.
Well, no, because remember the negatives now, 90's at the bottom and that's at the top. So
I said it was like right here. So then I used reference angle root 2, and then I did 180. Oh, it should be on. Oh, that's what I did. I said 360 was right here.
it should be
Yes.
So it should be quadrant 1.
All right, so what do we get for 305? You can just shout it out. 55, perfect, good. It's the difference between the x-axis, right, and the angle in the positive direction. So in the fourth quadrant, it's going to be 360 minus 305, and that difference is just 55 degrees. All right, sweet. So we have a little bit more space for negative 275, and that's because we need to do one step first. So whenever we talked about the bounds a lot yesterday, right? We have to, if it's in radians, add 2 pi. If it's in degrees, we have to add 360 before we can really evaluate an angle to get it kind of in bounds with what we can work with. So negative 275, is that out of bounds or in bounds? Out of bounds, right? Yeah, we can't work with that using the equations we have. So the first thing we have to do is we have to get that back in bounds, right? So what number do we have to add to 275, negative 275, to get it 360, right? Because whenever we're working in degrees, the way we ensure that an angle stays exactly the same for us is we have to add a full rotation. And a full rotation is going to be 360 degrees. So the best way to do that would be 360 minus 275. Oh. Minus 275. Carry the 1. Comes a 5. Got to carry that 1. You guys agree with 85? 85 degrees. So great. Now that we have our angle, we're good. We're inbound. So once you have an inbounds angle, right, what do we have to do when we're evaluating for a reference angle? What's the first step? Find the quadrant, right. So what quadrant is 85 degrees in? 1, exactly, because it's between 0 degrees and 90 degrees. So then what's our reference angle? 85, perfect.
Right. That's exactly.
Alrighty, so now, if you need a new page, that's fine. I think this was the second handout you got. So you can take a second to glue it into your notebook.
And then also take out your unit circle because we didn't fill in the positive and negatives going around. So take that out also. So we can fill in.
Your
positive
like
and
master
negative.
unit circle that you filled in everything on.
Why would you do that? You are here.
What are you looking at?
I just looked around.
You're out of one spot, brother. Not this one.
Yeah. Don't do that.
You're gonna get the, don't do that. Go get Eagles, for real. That's funny. Stop.
Who said anything about that?
I know you heard that conversation.
I don't think we try. What?
You heard that stutter. You heard her cough, bruh. Oh my God.
Does everyone have that glued into their notebook now? Yes, yes. All right, great. So, trig signs on a unit circle. When we're working on a unit circle, there's kind of the three main ingredients, right? It's sine, cosine, and tangent. And so, what letter is sine? Oh, sorry, that was a bad question. So, is it X or is it Y? Yeah, no, I worded that. That's on me. Y, right. Sine is Y. What about cosine? X, right. And then what's tangent? And then tangent? Y over X, right. The way I've always kind of remembered tangent is it's kind of like slope. So rise over run, if you remember that, Y over X. All right, so one thing that's really important for us is on a unit circle, realizing where these three ingredients are positive and where / when they're negative. And so the mnemonic device, a smart trig class, which hopefully we are when we're working with the unit circle, even though it's pre-calc, right? A smart trig class is going to be how we remember. And so what quadrant is this? Yep. What about this? And then, yep. And so that's exactly how this goes. This is for quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And what it's really telling you is which one of the ingredients are positive in that quadrant. So what do we think that A stands for? Apple, acetaminophen, anything math related? Alexis? Okay, so that A is going to tell us that all three are positive. Yep. So you can write that whatever underneath. A means all. And as you can see over here, sine, cosine, tangent, they're all positive. So what do we think that means for their sister function? So what's the sister function of sine again? Cosecant, right. It's kind of like flipped. It always feels like it should be secant, but it's cosecant. And then what's the sister for cosine? Yep. And then tangent. Yep. So what's it mean for two functions to be sister functions for us? Reciprocal, right. So reciprocal, it's a number, and then a number's reciprocal is when you just exchange the numerator and the denominator. Downstairs comes up and upstairs goes down, right? So what do we think the sister functions, are they positive or negative when all three of these are negative, or positive, sorry. So does a number change its sign when you flip it? Nope. So if it's like -7/5, then its reciprocal would be -5/7, right? It doesn't change its sign. So great. So that's why we've kind of been hammering home what the sister functions are. Because by remembering the main ingredients, by remembering sine, cosine, and tangent, when they're positive and negative, you actually get all 6. Because whenever sine's positive, cosecant's going to be positive. Whenever cosine's positive, secant's going to be positive. And then whenever tangent is positive, cotangent's going to be positive. Does that make sense? We good with that? Good. So then what do we think the S in SMART stands for? Sine. Exactly. Great. So then what quadrant are we in over there? 2. Right. So that means the only main ingredient between sine, cosine, and tangent that's positive in the second quadrant is sine. So then if I were to give you an angle in the second quadrant, let's say 3 pi over 2, right? And I were to ask you, was the sine positive or negative? What would you say? It's in the second quadrant.
Positive and negative.
3 pi over 2. Think about it.
But that's, positive and
Yeah, you're right. You're right. I was flipped. I meant 3 pi over 4. Yeah, 3 pi over 4. Would be in the second quadrant, right? So that means the sine value for that is positive. Yeah. So if sine is positive, what about cosecant?
it's negative. Wait, no, it's positive.
Cosecant's positive, right? So I want you guys to write in along.
So it's reciprocal. Reciprocal is positive too.
Yep.
Okay.
All right, so if you guys can come back. So if sine is positive, right, that means in the second quadrant, cosecant is also going to be positive, right? And so then what's the sister function for cosine? Secant, right? So in the second quadrant, secant is going to be negative. Yeah.
It's really there?
Oh, yeah, like how cosine has one at the end.
Yeah,
Yeah.
they spell sine,
Yes.
but we just abbreviate them with 3 letters.
Yeah.
Yeah, it's just the abbreviation.
Sin.
Yes. And so then what's the sister of tangent? Yep, so from what we already figured out, cotangent's also negative in the second quadrant. Good with that? Sweet. So then what do we think class in a smart trig class? What do we think class stands for? Yeah. And so then what do we think trig stands for? Yep. So if you need to write in here, that's going to be tangent. I'll just write tan. I'll get rid of the. Yeah. Oh, you don't like my T?
You're left-handed?
Yeah.
Twins. But why are you writing it?
Tan. There we go. That's a better T. And then we said the fourth quadrant is cosine, right? So that's going to tell us that in the third quadrant, out of sine, cosine, and tangent, right? Kind of like the main players. What's going to be positive? What's the only one that's going to be positive? Third quadrant. Tangent, right? And then cotangent has to be also by extension positive. Great. So then if we start filling in, let's see if this works. Yep. So then like we kept saying with the sister functions, third quadrant, sine's going to be negative. That means cosecant's going to be negative. Cosine's negative. That means secant's going to be negative. And then tangent is positive, so that means which other one's positive? Cotangent, good. I know it feels like it's getting repetitive, but this will be super helpful once you have an angle and you're trying to figure out what is positive and what is negative. And so from there, I'm just going to write, instead of writing all three, for that first quadrant, all are positive, right? And so getting back into that fourth quadrant, sine's negative. Like we said, that also means cosecant's negative. Tangent's negative, that means cotangent's negative. So then what are the two that are positive in the fourth quadrant? Yep, cosine and secant. Remember, cosine is sister of secant, and sine is the sister of cosecant. It's almost backwards from what it feels like it should be. Great. So from there, did you have them fill out anything else for the unit circles?
That was it. So
Great.
the next question that we're getting ready to cover is not on the review. However, it is on the quiz, so we need to lock in. So on the next slide, make sure you're copying these questions down because this is a quiz question. All of this that we're talking about is so you can understand this next concept that we're getting ready to cover. So you can just, yeah.
There we go.
So go ahead and copy this down. Again, this is a test question. You have 4 or 5 of these scenarios on the quiz. It's not on the quiz review, but it's on the quiz. So we need to lock in. Copy it down, and then we'll give you a minute. You don't need a lot of space because you're only going to name the quadrant. So we'll give them about 2 minutes to write it down, and then you can
Yeah.
research them.
Mhm.
I don't even know why I make them. Some of them made
So once you have A, B, C, and D down, and then also the name the quadrant, if you could just put your pencil or pen down, that'd be great. That'll let me know you have everything copied. We're going to talk through A together, and then you'll have a chance to try B, C, and D by yourself. We ready?
Yes.
Great. So, the way we kind of approach these problems, right, is kind of process of elimination. You figure out which quadrants it's not in, and then if you do it right, you should eliminate 3 out of the 4, and then you can figure out which one it is in. So, could someone read A for me? So, it's sine of theta, right, is that less than or greater than? Less than 0. So, if sine is less than 0, does that mean it's positive or negative? Great. So when sine is negative, that means it's not positive, right? So Is sine negative up here or down there? Bottom, right. So you can think of this two ways. You can either use the mnemonic device and draw out this circle on your quiz, right? And then you have all three and you can just keep referring back to that. Or you can think of sine as y and cosine as x, right? So if sine is less than 0, that means y is less than 0. So that's going to be below the x-axis. So the way I think about this is it can't be up here, right? So then we only have 2 quadrants left, and that's where we're going to use the second piece of information. So cosine is less than or greater than 0? Greater than 0. So is that going to be on the left-hand side or the right-hand side? Right-hand side, exactly. So then with the second piece of information, we can rule out that quadrant, and so then we have only 1 quadrant left. So give me on your fingers what quadrant that leaves us. Yep, 4th quadrant, perfect. So right next to it, you can just write 4th quadrant. And honestly, it might help while you're doing these problems to just kind of draw out a quick unit circle. So as I was doing that last one, and then you're like, okay, sine is less than 0, so cross out those 2, and then cosine is greater than 0, so cross out that one, and then you know you're left with quadrant 4. Yep. Great, so now B, tangent is greater than 0, and secant is greater than 0. So what's the sister for secant? Cosine, right. So by telling us that secant is greater than 0, they're also by extension telling us that cosine is greater than 0. And so I'm going to give you guys about 30 seconds. Try to use the process of elimination to figure out what quadrant we're in. Can you guys hold up your finger with which quadrant you think B is? We're getting 1? Good. So let's work through that one together real quick. So we all said it was 1. And using our information, tangent of theta is greater than 0. Well, using our mnemonic device, which is, what? Could someone remind me? The mnemonic device? Yep, exactly, a smart trig class. So where is tangent positive? Using our mnemonic device, a smart trig class. Well, I know all of them are positive in quadrant 1. And then smart, no, that's sine. Trig, okay, that's talking about tangent. So that leaves us just 1 and 3, and then class is only cosine. So that tells us quadrant 2 and quadrant 4 out of the question. So then secant is greater than 0. And like you said, the sister function for secant is cosine. So where secant is greater than 0, cosine is greater than 0. So which 2 quadrants is cosine greater than 0? 1 and 4, right. So that means 3 can't be it. And we're only left with quadrant 1, which is what you guys said. Perfect. So now I'm going to let you guys try C and D on your own. But before I do that real quick, what's the sister function for secant? Cosine, right? What about cotangent? Tangent. And then cosecant? Sine. Great. And I would just write like I wrote below. If I were you guys, then I needed help remembering as I go through the problem, I would just write it right below because they just mean the same exact thing.
I'm sorry. That really is good.
So we should be busy figuring out which quadrant C and D are in.
You said it's in the quadrant two. Hold on, let me get D first. Let me get Cot is coast rate. Coast over. Cot is, yeah, sorry, right? Yeah.
Yep.
So we looking for coast or something? For D, yeah, so we're for cotangent, you're looking where that one is less than 0. So you're looking for where tangent is negative. And then for. Oh, we're looking for where tangent is. Sine over here.
Okay.
So we're looking for where sine is positive.
That's what we got all again.
All right, so if you're still working on D, keep on working, but we're going to start going over C. So hold up your finger. What do you think? What quadrant you think C is in? 2, 2, looks pretty unanimous. Yep. All right, so that's what we'll check. And then what about D? What are we thinking for D? Quadrant 2 again? All right, we'll see. So if you want to do kind of the process of elimination that I went over for A and B, that's great. But if that strategy doesn't really jive with you, another strategy that you can use is writing in where it's positive. And the way I would do this is if you look for C, so secant theta is less than 0. That means I need to figure out where cosine is less than 0. And cosine, I know, is only positive on the right side of our coordinate plane. So I can write it out, and cosine's positive here and here, and negative here and here. And remember, I need cosine to be negative, right? So then I can just cross out these two, and it leaves quadrant 2 and quadrant 3. And so with the second piece of information for C, we're looking for where sine is greater than 0. And remember, sine, we kind of can think of that as just the y value, right? And so y is only going to be positive above the x-axis or on the top of our coordinate plane. And we need it to be positive, so it's going to be the two that are left, it's going to be positive here and negative there. And so we needed the first piece of information to be negative, and then the second to be positive. So quadrant 3 doesn't work, and we're left with quadrant 2. So you guys were right on the money there. And so then finally, the letter D tells us cotangent of theta needs to be less than 0. And cotangent theta and tangent theta are the two sister functions. So we need to figure out where tangent is less than 0. But we know tangent is greater than 0, according to our picture up here, in quadrant 1 and quadrant 3. So quadrant 1 and quadrant 3 are going to be no dice, and we're only looking at quadrant 2 and 4. And for that one, we need cosecant to be greater than 0. And for cosecant to be greater than 0, that means sine is greater than 0 because of the sister functions. And so where sine is greater than 0, remember sine goes right along hand in hand with y value. So where the y value is positive, and that's only going to be, just like you guys said, in quadrant 2. So you guys are right on both of those. Good job there. Do we have any questions with naming the quadrant in which the angle lays? Does it kind of make sense how you can figure it out with x, y, and then slope? Or you can figure it out with a mnemonic device, right? What's that mnemonic device one more time? Yep, a smart trig class. So tells us all. Smart means sine and its sister. Class trig tells us it's tangent and its sister cotangent. And then finally class means cosine and secant are the only ones that are positive. So great. So now this one, I'll give you guys about 30 seconds to write down example 3. Just write down, find the exact values of the remaining trig functions. Is this one the last example? Okay. And that right there, right above the 2, like it almost looks like it should be an exponent or something. That's just a comma that separates the 2 pieces of information. Great, so a problem like this where we need to find the remaining trig functions. So the first thing we need to do when we see a problem like this is figure out what quadrant we're working in. And so is this tangent? I know it gives us an exact value for tangent, right? It gives us 1/2. But during this step, we just need to figure out if that's positive or negative. So is 1/2 positive or negative? Positive, right. So tangent is positive. And then sine is less than 0. So does that mean sine's positive or negative? Negative, right. So take a couple seconds. It's just like the problems we were doing on the previous slide. That's the first step for this problem. We need to figure out which quadrant we're working in. So we need to find the quadrant where tangent is positive and sine is negative. So using this picture up here, there we go. Using this picture up here, hold up your fingers with which quadrant you think we're working in. 3, 3, 3. Yep, exactly. We're working in quadrant 3. Good, so I would mark that somewhere. You'll see on the quiz review answer key, I try to say which quadrant we're in by just going Q, 3. And so from there, that's great. So now then we look at tangent, because tangent's the one that gives us kind of the more information, right? It gives us that exact value. And so with that exact value, it said tangent equals 1/2. So what's tangent in terms of x and y? Yep, so for a problem like this, and this is a super vital step, we think of tangent as being y over x. So then, if tangent equals 1/2, then that means y equals 1 and x equals 2. Good. And now from that, we have our y value, we have our x value, and the next step is to find our r value, right? Because this information doesn't say that we have to be on the unit circle. So that means we have to actually compute our r value. So does anyone remember the equation we used?
R squared equals y squared.
Yep, there we go. That's the fancy name. Pythagorean theorem. So when we're computing r, we use r squared equals x squared plus y squared. So in this problem, r is going to equal the square root of 2 squared is 4. Two squared is 4, and then 1 squared is just 1. So then what's our r value? Root 5, exactly. Good. So are we on the unit circle?
No, not yet.
No.
Not yet.
So how do you know we're not on the unit circle?
Because that.
That's one way to think about it, right? So r has to equal 1. Only when r equals 1 are we on the unit circle. Otherwise, we're off the unit circle. And that's why it's so important to compute r. And so then we're going to be using these 6 equations a lot for finding the 5 remaining trig functions. So we already have tangent. So let's start with the easy one, right? Which one do you think we should start with if we already have tangent? Cotangent, exactly. Why do you think cotangent? You just flip it. Exactly. You can just flip it. So what's our cotangent of theta going to be?
2/1.
Yep, exactly. Cotangent of theta is going to be 2/1. Or just 2. Is anyone confused with how we kind of made that jump? Or does it make sense? Yep. So cotangent of theta equals 2. So now we've already found one of the 5 remaining trig functions. Next, we can start with whichever we'd like. Let's start with sine. So what's the equation we have for sine? X. Y over r. We have some x over r. We have some y over r. Y. Yep. So whenever we think sine, we think y. If we're not on the unit circle, it has to be y over r. So what's our y value here? 1. And what's our r value? Yep. 1 over root 5. But there's one thing we're still missing here. Well, 2 things, really. Who can think of one of the 2 things that's not quite right about our answer? Yep, can't have a radical in our denominator. So we have to rationalize. And we rationalize by multiplying the top and the bottom by root 5. So that's going to give us our sine value as root 5 over 5. Does everyone agree with me? Great. So what's the next one? Which one should we do if we just did sine? Cosecant, right. Do the sisters together. It's just going to make your life easy. And you can really do it really quick, right? Because we saw that sine was 1 over root 5. And that reminds me, right? I said there's 2 things wrong with that answer. We rationalized, that's 1. There's another thing wrong with that. We said our sine value was less than 0. This is a positive sine value. And that just happened because, let's think about it. We were in quadrant 3, right? And so we said tangent was 1 over 2, which is fine. But really, our tangent was negative 1 over negative 2. Does that make sense? Because the cosine and the sine were negative. Because the x was negative and the y was negative, right? So that means our sine value, yeah, it's root 5 over 5, but it's negative root 5 over 5. And that's our final answer.
Why didn't you put a bottom 5?
Oh, yeah, you're 100% right. Thank you. If you ever see me make a mistake, just shout it out to me. Be like, Mr. Suchi, that's not how that should look. So are we good with how we got sine? Cool. So then I want you guys to try to do cosecant by yourself. Hopefully it takes you about 10 seconds. What? Mhm. Yeah. I think I think we should be able to finish it up. Great. So can someone raise their hand and tell me what they got for cosecant and theta? What'd you get?
I did everyone except for the one.
Yep, so -5 over root 5 is all right, but then you have to rationalize it again. So what I would say is if you had to rationalize for one of the sisters, so we had to rationalize for sine, right? Go back to the beginning, right? And just use this for cosecant. Does that make sense? So then we know sine is 1 over root 5. So then cosecant is just going to be root 5 over 1. So you can flip, that's the power of the equal sign, right? 1 over root 5 is equal to negative root 5 over 5. So flip the one that makes it easier on yourself, right? So then our answer is going to be negative root 5 over 5. And really I should have gone back and added the negative there. Great. Yep. And so from there, we're left with cosine and secant. So are those going to be...
Okay, so cosecant, what is our cosecant going to be again? Is it negative root 5 or is it negative root 5 over 5?
It's negative root 5.
Yep, just negative root 5. Thank you, Ms. Bryant.
So our cosecant is just negative root 5. Negative square root of 5, that's it.
And all I did was flip this one, right?
Alright, so what's our next one we gotta do?
Yep, so I would always start with, you guys come back, I would always start with one of the main ones. So I would always start with tangent, sine, or cosine. And so cosine, looking back at the board, right, cosine is x over r. So what do we say our x value is? 2. And then what do we say our r value is? Root 5, yep. And then what's the one other thing we got to add is a negative sign. Why do we have to make that negative? Yep, that first step when we said it, we were in quadrant 3. That's what we're figuring out right there. It tells us sine is negative and cosine is negative. So it's really important when you're figuring out the remaining trig functions that not only does that mean sine's negative, that also means cosine's going to be negative. So then cosine's going to be negative 2 over root 5, and then when we rationalize it, we're going to multiply the top and bottom by what? Root 5, yep. So that's going to leave us with negative 2 root 5 all over 5 for our cosine of theta. Does that make sense? So now we have 4 to the 5. We said our cotangent was 2. We said our sine was negative root 5 over 5. We said our cosecant was negative root 5. And then we said our cosine was negative 2 times root 5 over 5. So the last one we have is secant, right? So looking at secant, yep, root 5 over 2. And then is it positive or negative? Negative, right. Just because cosine is negative, secant has to be negative because they're sisters. So with secant, we're going to be left with negative root 5 over 2. All I did was I flipped this one. I put the r on top, and I put... What? What do you mean?
Oh, you said 10. I thought you said 10.
No, that's why I was like asking if you have to do it again. Yeah, that's what we was looking for. Oh, no.
Oh, you're asking if we had to do tangent?
That's the one that gives
Yep, so if everyone could listen up real quick, that was a great question. Can you ask your question again for the whole class?
Nah.
Okay, so what she said was, we don't have to do tan, and you don't have to. So here where it says, find the remaining trig functions, what it's really alluding to is, we gave you tangent, and then we gave you one other piece of information, figure out the other 5. So, cool.
That's right.
That's all we got for today, right?
That's it, that's, after you